Hi, I'm Kian, and in this video I'm going to show you how to solve this partial differential equation. So you have the equation that partial of u with respect to y is equal to y times the partial of u with respect to x. So for these types, we call them separable partial differential equation, where we aim to make this hard-looking partial differential equation into an ordinary differential equation. And the way we do that, we basically introduce a function u. So we let that u is a product of a function of x, f of x, and a function of y, g of y. And we just basically follow the order that the question gives. So the partial of u with respect to y, basically we treat anything other than y as constant. So the left-hand side becomes f of x, stays the same, times g prime of y, because that's the derivative. And that's equal to y times, and then partial of u with respect to x is basically f prime of x in this case, because we're taking the derivative with respect to x, and then the g of y stays the same. Now we can see that we actually have an ordinary differential equation because we have g prime. We have kind of the notation that we are usually used to in a differential equation course, and we can actually manipulate this to make it an equality that actually makes more sense. So we can make the y's on one hand side and the x's on the other hand side. So if we do that, we get to this stage. G prime of y over y times g of y is equal to f prime of x over f of x. But for this to hold true, let's say we're kind of visualizing for an expression with respect to y to equal an expression with respect to x, the only way that this can happen is both of them equaling a constant. Because, for example, how can 2y and 2x both equal each other, or 2y and 3x? The only case that this can happen, because the variables are different, is for both expressions to equal a constant, and therefore equality holds. So we let both expressions to equal a constant c. And basically, we have introduced two separate ODEs, or ordinary differential equation, to solve. So for the first case, I'm going to start with an easy one, which is the f prime of x over f of x equal to c. So I'm just going to rewrite it a little bit different. I'm going to use a notation y, but it's kind of much easier to solve with it. So I'm going to write dy dx, which is basically f prime of x, times 1 over y, which is basically f of x. I'm kind of changing the notation a bit. I hope you don't mind, but equal to c. And again, this is a kind of a usual differential equation, a separable case. So we can integrate both sides, and if we do, we get ln of absolute value of y is equal to cx plus k. And if we solve for y, which again in this case is the f of x is equal to k times e to the cx. So that's basically the solution, or a general solution, to the one of the ODEs. Now we get to the other ODE, which is the harder one, and that's the one that's g prime of y over y times g of y is equal to c. So how do we solve this? So again, we want to kind of manipulate it a different way. So what we do is that we basically multiply y by both sides. So we get g prime of y over g of y is equal to cy. Now we can actually integrate both sides. So the left-hand side is just natural log of absolute value of g of y, and the right-hand side, we're just integrating with respect to y. So it becomes cy times y squared over 2, and then plus a constant, let's say alpha. And now just solving for g of y, we raise both sides to the power of e. So the answer for our g of y is alpha times e to the power of cy squared over 2. So now we have successfully found the answer to the two ODEs, and now the only thing left is to basically multiply them and find the general solution to the partial differential equation. So if we multiply the answer we found for f of x times g of y, the k times a becomes another constant. I'm just going to call it b, or beta in this case. And then when we multiply two powers of e, we can actually add them by the property of powers. So all in all, it becomes beta times e to the power of cx plus cy squared over 2. And you can actually check it by taking